Hi there, I'm Helen Carville. I'm the course leader for Maths and Further Maths at QE, and I'd like to welcome you to a mini maths lesson on binomial expansion. I'd like to start by doing a little bit of work on expanding brackets. Okay, let's start with a plus b squared. Remember that means a plus b multiplied by a plus b. There are lots of different ways to multiply the two brackets together. I'm a bit of a fan of the grid method, so I've shown you here how you would use the grid method to multiply those two brackets together. Next thing you need to do is collect any like terms. And I can see on that diagonal I've got two AB terms, so I can combine those together. Putting that all together, I can see that the expansion of a plus b all squared is a squared plus 2ab plus b squared. Let's extend that to a plus b cubed. That means a plus b multiplied by itself 3 times. We can make that a little bit easier by using our previous result that a plus b times a plus b is a squared plus 2ab plus b squared. Again, I'm using my grid method here to work out the product of those two brackets. That helps me to see that I do have some like terms again. So shaded in green, you can see that I've got two a squared b terms, and in blue, I've got two a b squared terms. Simplifying that gives me this tidied up version of the expansion a cubed plus 3a squared b plus 3ab squared plus b cubed. I can continue that method to work out a plus b to the power 4. You could try this yourself, it does take a little while to do it, but if you have a look you can see that we have an expansion there for a plus b to the power 4. Notice that it has 5 terms this time. It starts with an a to the power 4 term and ends with a b to the power 4 term. Now we could keep doing that for higher powers of the bracket, but let's see if we can look for a pattern to help us make some shortcuts. Okay, so I've put here the 3 results that we've got so far to try and help us see if we can spot a pattern. To help us find the pattern, it would help to see the previous expansions to the 3 that we already have. So that's a plus b to the power 1 and a plus b to the power 0. In red, I've added in the next 2 expansions, a plus b to the powers of 5 and 6. So I can see that every time I increase the power of the bracket, I get an extra term and the powers get higher. But let's try and look a little bit more closely at the terms that we have. Let's start by looking at the coefficients. The coefficients are the numbers in front of the terms. Here are the first 7 expansions. It would be helpful here just to look at the coefficients on their own first. So I've highlighted all of those in red. What I'm going to do next is take away all the algebraic terms and just focus on the coefficients. Here are the coefficients, and if you look, it does look like there is a little bit of a pattern. It's a little bit easier to see if I slightly change the triangle from being right-angled to equilateral. Now some of you might recognise this. This is Pascal's triangle, and it gives us the coefficients of our expansions. We'll have a look at it in a bit more detail. If you first of all look at the green triangle, you can see that the 2 numbers above the 4 are 1 and 3. Add them together and you get 4. Look at the blue triangle. The number 15 is at the bottom of the triangle. The 2 numbers above it, 10 and 5, add together to give 15. In fact, if you look at any number in the triangle and find the 2 numbers directly above, you'll see that they add together to give that value. So you can see here for the next row of Pascal's triangle, I can see that, for example, 7, I get that by adding the 1 and the 6 above it. The 35 I can see is the sum of 15 and 20. I can then work out the 9th row of Pascal's triangle by again adding pairs of numbers in the 8th row to give me the numbers in the next row. So for example, 7 add 21 is 28, 21 add 35 is 56. Okay, so we can see that there is definitely a pattern in the coefficients of the expansions. Let's now look to see if we can see a pattern in the algebra. Let's have a look again at the expansion of a plus b to the power 5. First of all, let's focus on the a terms. Notice how the powers of a decrease from 5 to 0. So the first term has a to the power 5, the second term has a to the power 4, all the way down to the last term, the sixth term, which is a to the power 0. Let's now look at the b terms. You can see that they now increase in power from 0 to 5. If you look at any term in the expansion, you'll see that the powers add up to 5. So, for example, in the second term, 5a to the power 4b to the power 1. Notice that the two powers, 4 and 1, add to give 5, which is the power of the original bracket. Now that we've spotted these patterns, let's see if we can predict the next expansion. So if you want to find the expansion of a plus b to the power 7, well, first of all, we know there will be 8 terms in that expansion, and we know what the coefficients are from the 8th row of Pascal's triangle. We know that in the terms of algebra, that the powers of a will decrease from 7 to 0, whilst at the same time the powers of b will increase from 0 to 7. See if you can work it out. Grab yourself a bit of paper and a pen and see if you can come up with the answer. Well, that's all very well as long as your two terms in the bracket are a and b, but what if you have something different? Can we extend the use of this pattern to find any expansion? Well, of course we can use the result for any expansion. If you look at the 4 examples here, any of those can be worked out using the patterns we've already found. I'm going to find the terms in the expansion of 2 plus 3x to the power 4. So I'll start by comparing it with the expansion of a plus b to the power 4. All I need to do here is replace all of the a's and all of the b's with 2 and 3x in the terms on the right hand side. My first line of working here shows me doing that. The second step shows me tidying up my working out, and then the third step shows the final answer. It's probably worth pausing the video here to take a little bit of time to work through that algebra. Here's another example. This one's going to be a little bit easier if I do it on the whiteboard. I want to find just the first 3 terms of that expansion, 1 minus 4x to the power 6. First thing I need to do is identify that this is how the expansion works for a plus b to the power 6. So there's the first 3 terms which we found earlier. Then I need to spot the fact that the first term in the expansion in this case is 1. And then I need to identify the fact that the second term in the expansion b is minus 4x. Really important there that I include the minus. Then all I need to do now is substitute for a and b into my expansion. So I've got 1 multiplied by 1 to the power 6, and then I've got b to the power 0. So my first term is the product, the multiplication of those 3 elements. The second term is 6 multiplied by 1 to the 5 multiplied by minus 4x to the power 1. And my third term, 15, 1 to the power 4 minus 4x to the power 2. My next step is to tidy up each of the 3 elements of each term. So that's 1 multiplied by 1 multiplied by, that's 1, anything to the power 0 is 1, plus, and then my second term, 6 multiplied by 1 multiplied by minus 4x, and then my third term, 15 multiplied by 1 multiplied by, now this is where I need to be a little bit careful, negative 4x all squared is 16x squared. I'm at the final step now, which is just to tidy up each term. So my first term is 1. My second term, 6 times minus 4x, that's minus 24x. And then my final term here, 15 multiplied by 16x squared, that's 240x squared. So there's the first 3 terms of the expansion of 1 minus 4x to the power 6. So we've worked through 2 examples. Now it's time to try some yourself. You'll find a document with 4 questions in. Why not have a go and then come back later in the week and check your answers. Also later in the week there will be another mini maths lesson. This one will particularly look at using the ClassWiz calculator, which is the one recommended for A-level, and also it will introduce you to a few maths apps that you might find really useful. I'd also encourage you to have a look at the QE website. at the Maths and Further Maths pages. There's lots more information there. There's further mini lessons. There's also a couple of quizzes for you to try too.